Introduction. Try to adjust the volume of the music by moving the slider. Try clicking the dimmer to dim the lights. The volume control slider and the dimmer use a potentiometer to tap a fraction of the applied voltage. Introduction. In this lesson, you will learn the principle of the potential divider, the principle of the potentiometer, to use the potentiometer to measure the EMF of a cell, determine the internal resistance of a cell, compare resistance. Click on each of the components to identify them. Then click the Assemble button to set up the circuit. Click on the switch. Does the bulb light up? Answer: no, the bulb does not light up. Drag the slider of the rheostat to move it slowly to the right. Describe and explain the change in the brightness of the bulb. Answer: the bulb gets brighter because the potential difference across it increases. Click on the bulb. Click on the switch, then drag the slider of the rheostat slowly to the right. How does the voltmeter reading change? Answer: voltmeter reading increases. A potential divider consists of two resistors of resistance R1 and R2 connected in series. If V is the total potential difference across the two resistors, then the potential difference V1 across R1 can be deduced as shown. Click on the switch. Key in the values of R1 and the calculated values of V1. Summary. A potential divider is used to tap a fraction of the supply voltage. A rheostat or two resistors connected in series can be used as a potential divider. The voltage V1 tapped off from a voltage V by a potential divider is V1 equals R1 over R1 plus R2 multiplied by V. Click on the potentiometer button to view the labels from the various parts of the potentiometer. The principle of the potentiometer is similar to that of the potential divider. A driver cell of EMF 2.00 volt is connected across the uniform wire AB of length 100.0 cm. A high resistance voltmeter is connected to the NA and a jockey. Click on the switch button. Touch the wire AB at various points. Observe how the potential difference V between the NA of the wire and the jockey varies. Click on the conclusion button. Summary. A potentiometer consists of a uniform wire, usually 1 meter long, stretched between two terminals, a driver cell of a constant EMF, and a switch. The potential difference across a length L of the potentiometer wire is directly proportional to L. A voltmeter can be used to measure the EMF of a cell. Click on the voltmeter. Click on the voltmeter to replace it with the potentiometer. Click on the switch. Touch the NA of the slide wire AB. Note the direction of deflection of the galvanometer pointer. Now touch the wire at B and note the deflection. Try to find a point on the slide wire where the pointer of the galvanometer is not deflected. What is the balance length L? Answer: 75.0 centimeter. What is the EMF of the dry cell? Click the calculation button. Answer: 1.50 volts. Click on the switch. Touch the slide wire to find the balance length L for the standard cell of EMF E1 equals 1.018 volts. Click cell of EMF E2 to connect it to the potentiometer. Touch the slide wire to obtain the balance length L. Click the calculation button. Click on the switch. The reading of the high resistance voltmeter equals the EMF E of the dry cell. Drag the resistor of the resistance R to connect it between the point B and Q. The voltmeter now measures the potential difference V across the resistor. The relationship between the EMF E and the potential difference V is E over V equals R plus R over R, where R is the internal resistance of the cell. Click on the voltmeter to substitute it with the potentiometer. Click on the switch S1. Touch the slide wire at different points until the galvanometer is balanced. Now click on the switch S2. Touch the slide wire at different points until the galvanometer is again balanced. How is the value of the internal resistance R of the cell calculated? Click the calculation button. When two resistors of resistance R1 and R2 are connected in series, the same current I flows through both the resistors. The potential differences across the resistors are as shown. Click on the switch. Touch the slide wire to find the length of the slide wire, which will balance the potential difference V1 across the resistor of resistance R1. Note the balance length L1. Click the resistance R2 and touch the slide wire to find the length L2 of the slide wire, which will balance the potential difference V2 across the resistance R2. If the resistance R1 equals 2.0 ohm, calculate the resistance R2. Click the calculation button. Summary. The potentiometer is used to determine EMF of a cell, determine the internal resistance of a cell, compare resistance. Click on the switch. Touch the slide wire at A, then at B. What do you notice about the deflection of the galvanometer? Answer. When the jockey is at A or B, the pointer of the galvanometer deflects in the same direction, that is, to the right. Can a balance point be obtained at the potentiometer wire? Answer. No. What is the fault in the circuit? Rectify the fault to obtain the balance point. Answer. The dry cell is connected the wrong way. Click on the switch. Touch the slide wire at A, then at B. What do you notice about the deflection of the galvanometer? Answer. When the jockey is at A or B, the pointer of the galvanometer deflects in the same direction, that is, to the left. Can a balance point be obtained at the potentiometer wire? Answer. No. What is the fault in the circuit? Answer. The potential difference across the whole length of the wire AB is less than the EMF of the dry cell because the potential difference across the rheostat is too big. Try to rectify the fault so that the balance point can be obtained. Click on the switch. Touch the slide wire to obtain the balance point. What is the balanced length? Answer. 5.0 centimeter. To increase the accuracy in the measurement of the EMFE of the cell, the balance length should be greater. How can this be achieved? Answer. By reducing the potential difference across the wire AB. This can be done by increasing the resistance of the rheostat. Drag the slider of the rheostat to increase its resistance. Then try to obtain the new balance length. Summary. When a balance point is not obtainable, the possible faults are: the cells in the circuit are connected wrongly. the potential drop across the slide wire is too small to balance the voltage being measured.